Good day, learners. My name is Jacques Botha and I will be responsible for today's lesson, which is on the lithosphere and the rock cycle. Before we can start with today's lesson, we first need to revise some of the previous work. The theme was Earth and the Earth's spheres. Now we've been taught that the Earth consists of 4 spheres, naming lithosphere, hydrosphere, atmosphere and biosphere. Now the lithosphere is all the solid parts of the Earth. That is sand particles, it is rock particles, all the solid particles. Hydrosphere is all the water found under, on and over the Earth's surface. The atmosphere is all the gases that surround the Earth. And the biosphere is all the living parts, all the life on Earth. We also know that there are definite interactions that exist between the different spheres of the Earth. The spheres of the Earth can therefore not exist in isolation. A small example is a tree which is growing in soil. The soil, which is part of the lithosphere, anchors the tree through the roots, and the soil also has a lot of nutrients which is taken up by the tree. So the lithosphere actually plays a very important role in the tree's life, and the tree is part of the biosphere. Right, moving on to the layers of the Earth, or then the structure of the Earth. To simplify the layers of the Earth, or to simplify the topic, we've chosen only the 4 main layers which we will give attention. The first layer is the crust. That is the most outer layer. Then beneath the crust you'll find the mantle, and then beneath the mantle it's the outer core, followed by the inner core. Firstly, the crust. This is the Earth's most outer layer. It is more or less 60 kilometers thick. Then the mantle. The mantle is more or less 2,900 kilometers thick. This is the layer just beneath the Earth's crust. It is composed of hot semi-rock or semi-solid rock, which is called magma. The rock is hard in the upper part of the mantle, but the lower down you go into the mantle towards the core, the softer the rock becomes, and this softer rock is also known as magma. Then you get the next layer which is called the outer core. This layer is found beneath the mantle. Now the outer core is 2,200 kilometers thick. It's also a very thick layer. It is made up of molten iron and nickel, and the outer core is also responsible for the Earth's magnetic field. Then the most inner layer is called the inner core. It is the center layer. It is also the hottest layer of the Earth. Now you would expect that the inner core would also be liquid in texture, but it is actually a solid layer, and the reason for this is it experiences immense pressure from the layers which is situated above the inner core, and therefore the inner core, the composition is the same as the outer core, naming it is made up of iron and nickel, but it hasn't got a liquid texture, or it's not in liquid phase, it is in a solid phase. Then the lithosphere, as we've highlighted earlier, which is one of the spheres of the Earth. It is also in some talk about the lithosphere as solid earth. It is the rigid outermost layer of the earth composed of the crust and of the upper mantle. So those are the two things that makes up the lithosphere. It is the crust and the upper mantle. It is divided into tectonic plates, which are large rigid segments of the lithosphere that move slowly over the underlying mantle. Now these plates forms the continents, like the Africa continent and the North and the South American continents. These are the plates which are referred to here. And the Earth's surface features includes mountains, continents, and ocean basins. All of these things forms part of the lithosphere. Then we move to the rock cycle. Firstly, the definition. The rock cycle is a continuous process that describes the transformation of rocks from one type to another over a very long time. This is very important. It's not 1 year or 2 years, it is millions and millions of years. It involves three main rock types, namely igneous rocks, sedimentary rocks, and metamorphic or metamorphic rocks. Right. It's called a rock cycle, and you can see from the diagram here with the different arrows, you can clearly see why it is called a cycle, because the arrows move in a concentric circle. It starts at one point and it also ends at the very same point. To describe the rock cycle, you can actually start at any point, but to make it simple, I always tend to start with magma. And we know magma is formed in the mantle of the earth, and then when there's weak points or weak areas in the crust, the magma tends to be pushed upwards and then it can be exposed to the surface of the earth. But in short, when magma cools down, it solidifies or it crystallizes to form igneous rocks. Examples of igneous rocks are basalt and granite. Granite normally is formed inside a volcano beneath the surface, where crystallization of the minerals is very slow, and the crystals in granite therefore is big. Now basalt has got the same composition, but basalt forms outside the volcano, where this magma is pushed out to the outside of the volcano. It turns, or it gets the name lava when it exits the volcano, and when this lava solidifies quickly, it forms igneous rock called basalt, right? Then igneous rocks can be weathered away, meaning that igneous rocks can be broken down into smaller particles or sediments. Now these sediments are, you can see the little sediments there in the picture. Sediments are things like sand and gravel. So just remember the process where igneous rocks are broken down to sediments. This process is through weathering and erosion, and the definition of weathering and erosion is mentioned there. So weathering is the process by which rocks, in this case igneous rocks, are broken down into smaller particles through the working or the action of either wind, rain, ice, and sometimes also temperature. Erosion, on the other hand, is the process by which weathered materials, so weathering has already occurred, and then these materials are transported from one place to another through or by means of wind, water, or ice. Then these sediments can then come together to form sedimentary rocks. Now the sediments normally moves over long distances. It can be in rivers or it can be transported by wind, and then they are deposited, and When they are deposited, we talk about deposition or dropping off of the particles, and then those deposited particles started or are compacted when millions and millions of tons of these deposited particles start to squeeze one another, or they settle on top of one another, and then the small little openings between these particles are filled up by minerals that comes from groundwater, and then eventually a new rock type is formed called as sedimentary rock. Examples of sedimentary rocks are sandstone. Sandstone is when normal sand particles are compacted and cemented together to form sandstone. Limestone is formed when seashells and broken coral reef particles are compacted together to form a sedimentary rock called a limestone. Shale is formed when very fine, very fine particles or clay particles are compacted together. Then a sedimentary rock called shale is formed. Then sedimentary rocks can change into metamorphic rocks, and that is when sedimentary rocks are also compacting on top of one another, and then when they get exposed to immense heat and pressure, they undergo a change, and we call that metamorphosis, and metamorphic rocks are formed. Very important to note, you need an immense or a big amount of heat and pressure to change a sedimentary rock to a metamorphic rock. Examples of metamorphic rocks are quartz. Now, quartzite comes from sandstone. So when sandstone undergoes metamorphosis and forms a metamorphic rock, it forms quartzite. When limestone experiences this big amount of heat and pressure and undergoes metamorphosis, it forms marble. And when shale changes to a metamorphic rock, it forms slate. Then metamorphic rocks, when they settle down deep inside the earth and they get compacted and move downwards closer towards the mantle, then metamorphic rocks can become part of the mantle again, and the whole process can repeat itself. And then that is where the term rock cycle comes from. It is just important to know, moving to this slide, that the rock cycle is not always just a circular route. If we quickly start here with magma in the volcano, when magma is exposed to the surface, or it moves up, cools down, and it crystallizes, it can form an igneous rock. When igneous rocks are eroded away and weathered away, they form sediments, as we saw. When those sediments compacted and are cemented together, we form sedimentary rocks. But the sedimentary rocks, again, can be eroded away to form sediments and again compacted. So there's a little sub-circle or sub-cycle that can happen here also. Now, when sedimentary rocks undergo heat and pressure, they form metamorphic rocks. These metamorphic rocks again can be weathered away to form sediments again. And then here you can see there's a little sub-cycle that can happen here, from metamorphic rock to sedimentary, or to sediments, back to sedimentary rock, metamorphic rock. So there's also dynamics happening here. Looking at the igneous rocks, when igneous rocks touches the mantle, they can become magma. So there's a sub-cycle here. When this magma cools down, it forms igneous rocks. And when igneous rocks undergo an immense amount of heat and pressure, an igneous rock can become a metamorphic rock. So, right, just quickly, I've included this also. This is just to show to you how, and I've already discussed this, how sedimentary rocks have got their metamorphic equivalents, meaning that when sedimentary rocks changes to metamorphic rocks, the three examples that was stated here, when sandstone, which is a sedimentary rock, changes to a metamorphic rock, it changes to quartzite. When clay particles form shale, and the shale changes to a metamorphic rock, it forms slate. And when seashells, or then coral, pieces of coral, when they compact, they form limestone, but when the limestone undergo metamorphosis, the limestone then forms marble. So learners, now it is time to do the quiz. You will find the QR code and also the link to the quiz. There's some exciting questions here. Navigate to the quiz, take your time and enjoy the quiz.